Hello guys, it's Feeling Zealous here, and today, continuing chemistry. Investigate the matter that makes up the world. Now, down of the way, get into it. Chapter 2. States of matter. Gases, liquids, and solids. What is different? What is different about the different forms of matter? Everything around us is made of matter. Not everything has the same characteristics. A glass of water is different from a sandwich, and both of these are different from the air you breathe. Even though all these things are made of matter. Some objects are solid, others are liquid, and others are gas. Right? These different forms of matter are called states. Why does matter have different states? What makes some matter solid while other matters are liquid or gas? The answer can be both found with the smallest piece of matter, the atom. Each form of matter is made up of individual atoms or small groups of atoms bonded together in clusters, called molecules. These atoms are always in motion. At the same time, the atoms are attracted to one another because of their charges. As we learned in the last chapter, together these two ideas help explain the different states of matter. They are known as the kinetic molecular theory of matter, or as the rock solids. Some matter is solid, such as a bicycle, ball, or even your own body. Solid matter has many different physical characteristics. Think of all the different solids that you come in contact with every day. A solid can be as hard as a rock, or as soft as a kitten's fur. It can be as big as a city skyscraper, or small as a grain of salt. Although they can look very different, solids have some important similarities. All solids have a fixed shape and a fixed volume. Solids hold their shapes because their atoms and molecules are tightly packed together. In a solid, the molecules are very attracted to each other. This strong attraction keeps the molecules held tightly together in a specific structure or arrangement. The molecules in a solid can only vibrate in place. They cannot move past each other or change their positions. In some solids, atoms and molecules are arranged in rigid groups called crystals. The crystals are stacked in a repeating three-dimensional pattern called a crystal lattice. Table salt, NaCl, is an example of a common crystal. In table salt, the sodium, Na, and chlorophene, Ci, atoms line up in a specific pattern to form the salt's crystals. There are many different types of crystal structures. Go with the flow, liquids. Anyone who has spilled a can of soda notices that a liquid is very different from a solid. A liquid is a fluid, and in case of soda, sticky water. Water, coffee, alcohol, gasoline, and blood are all types of liquid. Liquids have several common characteristics. Unlike solids, they do not hold their shape. Instead, they fill the shape of the container they're in. You pour water into tall glass, it will have a different shape than if you pour it into a shallow bowl. Even though the liquid changes its shapes, its volume remains the same, no matter what container you use. Also, the top of a liquid is usually a reflective flat surface. It's because the force of gravity pulls on the liquid's molecules and flattens its surface. Liquids are difficult to compress. When something is compressed, its molecules are forced into a smaller space. Just as in a solid, the molecules in a liquid are already closely packed together, which makes it hard to compress them anymore. The molecules in a liquid are constantly in motion. The attraction between the liquid's molecules are not as strong as they are in a solid. When a liquid's attractions keep the molecules close to each other, they are not in a fixed position. This allows the liquid's molecules to move past each other. The movement of molecules explains why a liquid can easily change its shape. Although a liquid's molecules can move freely past one another, they still tend to keep near one another. Liquids often stick together because of the forces that pull the molecules together. A drop of water on the floor will tend to stay in a drop instead of spreading out into a large, thin puddle. The intermolecular forces that attract the water molecules to each other keep the water together at the drop. In contrast, liquid with weaker intermolecular forces such as ethyl alcohol will spread out over a larger area. Molecular forces or forces between molecules are found in all substances. Most intermolecular forces bring molecules together, while some forces push them apart. A liquid whose molecules are held together by a strong intermolecular force. They behave differently from another liquid. Those molecules are held together by weaker intermolecular force. A liquid's intermolecular force affects its melting point, boiling point, and surface tension. The stronger the intermolecular force, the higher the temperature will be at which the liquid will melt and boil. All around you, gases. Gases are all around you. The Earth's atmosphere is made of gases, while solids and liquids are easy to see and touch. Gases are often invisible and odorless. One of the physical characteristics of a gas is that it can fill a container of any shape, size, or shape. Imagine a balloon. Balloons come in all shapes and sizes. Some are round, while others twist and turn to form fancy designs. No matter what size or shape the balloon is, gas molecules you blow inside will spread out to fill the balloon. Just as in solids and liquids, the molecules in the gas are constantly moving. Gas molecules vibrate and move freely past each other. Solid, liquid, and gas. In a gas, the attraction between molecules are much weaker than those in a solid or liquid. As a result, the molecules in the gas spread out much further than those in liquids and solids. The molecules are so far apart that gases are generally much less dense than fluids or this means gases can compress much more easily than solids or liquids. Compressing a gas reduces the space between its molecules. Because gas molecules are so spread out, they can mix freely with other gases. Gas laws. Unlike liquids and solids, the volume of a gas is not fixed. A gas can be compressed to a smaller volume by reducing the amount of space between its molecules. Changes in the volume of a gas can affect its pressure. Compressing a gas into a small container and a smaller volume causes molecules to bump into the side of the container, which increases the pressure of the gas. The volume and pressure of a gas can also be affected by temperature. Scientists have developed several laws to explain the relationships between the volume, temperature, and pressure of a gas. Avogadro's hypothesis. Hypothesis. Armando Avogadro was an intelligent Italian scientist who lived in the early 19th century. He discovered that two gases with the same volume, temperature, and pressure will have the same number of molecules. This discovery is known as the Avogadro's hypothesis. Another way of thinking of is known as the Avogadro's hypothesis. Hypothesis. Another way of thinking of Avogadro's hypothesis is to picture two identical containers. One containing oxygen gas and the other holding nitrogen gas. If the temperature and pressure are the same, each container will hold the same number of molecules. But what if different gases have molecules of different sizes? For example, equal numbers of tennis balls and basketballs will not fit into the same container because the balls are different sizes. So why can't the same number of differently sized gas molecules fit in the same container? The reason is that gases have an important property that's unlike solids and liquids. In a solid or liquid, the molecules are very close together. Gases are mostly made of empty space. Under normal conditions, the space is taken about by gases about 99.9% empty. There's a lot of space between the tiny molecules. Since there's a lot of space between the gas molecules, then the size of the molecules has a little effect on how many molecules fit in a given container. Measuring mass. Although they are related, mass and weight are not the same. Mass is the amount of matter is in the object, while weight is a measure of the force of gravity on an object. An object's mass remains the same no matter where it is. And an object's For example, an object has the same mass on the Earth as it does on the Moon. Its weight, though, is very different because the gravitational pull on the Earth is different from the gravitational pull on the Moon. On the Earth, an object's weight is very close to its mass, and we often use terms interchangeably. And that's for today, guys. Hope you guys enjoyed. Yes, I see you guys again very, very soon.